We can use the factor theorem and synthetic division to completely factor a polynomial that is higher than a second power polynomial. Determine whether x minus 5 is a factor of this polynomial, then find the remaining factors of the polynomial. If x minus 5 is a factor of the polynomial, that means that we should be able to divide it into the larger polynomial and get a remainder of 0. And we can show that through synthetic division. So I will first start out by writing out the coefficients and the constants. So 1, -7, +7, and 15. And since this is synthetic division, there will be a sign change, so I will place 5 inside of the box. And then we do our series of multiplications and additions. So I bring down the 1, 5 times 1 is 5, and then I add to get -2. 5 times -2 is -10. I add to get -3, and 5 times -3 is -15, and I add to get 0. So with no remainder, this shows me that x minus 5 is a factor of that larger polynomial. Then the second part of the question says to find the remaining factors of the polynomial. So to find the remaining factors of the polynomial, I'm going to go ahead and interpret this bottom row to see what the polynomial divided by x minus 5 is. So remember, 0 is the remainder. The -3 represents the constant. The -2 is the x term. And the 1 is the coefficient of x squared. So I have x squared minus 2x minus 3. So to find the remaining factors, I'm going to factor it into a binomial pair. So we have x and x. Factors of -3 that add up to -2 would be -3 and +1. I check. That's -3x. That's +1x. That does add up to -2x. So the complete factorization of this polynomial is the x minus 5 that was given to us, along with the two factors that I just found out, x minus 3 and x plus 1. Now later on we'll learn how to figure out how they came up with that x minus 5, but that is a topic for the next section. So let's do another one. This one says show that x minus 2 is a factor of that polynomial, then find the remaining factors of the polynomial. So just like we did on the previous example. So to show that it's a factor, I will write out my coefficients and my constant. We're doing this through synthetic division, so I will place a +2 inside the box, and then I will bring down the 1 and start multiplying and adding. So 2 times 1 is 2. You add to get -5. 2 times -5 is -10. You add to get -6. And 2 times -6 is -12. You add to get 0. And again, I'm going to point out the directions here. It says show that it's a factor. Since we're showing that it is a factor, that means that we should get a remainder of 0. And if you don't get a remainder of 0 on this, that you've made a mistake and you need to go back and figure out where your mistake is. So we have shown that x minus 2 is a factor of that polynomial. So I will interpret the bottom row. Remember, 0 is the remainder. -6 is the constant. -5 represents the x term, and 1 represents the coefficient of x squared. I factor that out into a binomial pair. So x and x. And let's see, factors of -6 that add up to -5 would be actually -6 and +1. This is a tricky one. So -6 times x is -6x. X times 1 is +1x, and that does add up to the -5x as my center term. So my complete factorization is going to be the x minus 2 that was given to us at the start, and then the two factors that we just discovered, x minus 6 and x plus 1. So let's try one more. This one says show that x plus 4 and x plus 3 are factors of that polynomial, and then find the remaining factors of the polynomial. So this time they give us two factors, then we're going to have to test both of them. Doesn't matter which one you test first, because either one of them will give you the correct answer. You do one first and then the other. You get to pick which one you want to do first. It really doesn't matter, but I'm still going to write out my coefficients and constants. And I'm just going to start with the x plus 4. So Since we're dividing by x plus 4, what goes in the box? Well, that would be a negative 4. Remember the sign change because we're doing synthetic division here. So I bring down the 1. Negative 4 times 1 is negative 4. I add to get 5. Negative 4 times 5 is negative 20. I add to get 3. Negative 4 times 3 is negative 12. I add to get negative 9. And negative 4 times negative 9, now that's positive 36. So I add to get 0. So this does show that x plus 4 is a factor of that larger polynomial. Now, I'm going to go ahead and interpret the bottom row. So that's negative 9 as a constant, 3x, 5x squared, and 1x cubed. So we're not quite ready to do our factorization on this yet because we have an x to the third power. So I'm going to show that x plus 3 is now a factor of what I have now, the x cubed plus 5x squared plus 3x minus 9. So I'm going to write out my coefficients and constant based upon that set of numbers. And then I will place a negative 3 for x plus 3 in the box. And I will do a synthetic division with this set of numbers. So notice I'm not going back to the original problem. I'm not going back up to there. I'm starting with what I was given with my last set of numbers here. So negative 3 times 1, that's negative 3. I add to get 2. Negative 3 times 2 is negative 6. Add to get negative 3. And negative 3 times negative 3 is positive 9. I add to get 0. So x plus 3 is a factor. Now I'm going to interpret this bottom row. 0 is the remainder. Negative 3 is the constant. 2 for 2x and 1x squared. And now I have a quadratic expression. So I can factor that into two sets of parentheses. So x and factors of negative 3 that add up to 2 would be positive 3 and negative 1, because 3 times negative 1 is negative 3. Inside terms is 3x, outside terms is negative 1x, and that does add up to the positive 2x in the middle. So I have that portion factored completely. So the entire factorization of this x to the fourth power polynomial would be the two factors that was given to us. That was the x plus 4 and the x plus 3 in the original problem. And then the two factors I just discovered, which is actually another x plus 3 and then x minus 1. So since there's two x plus 3 binomials in the factorization, another way of writing this answer could be x plus 4, x minus 1, and with two x plus 3 factors, I could write that as x plus 3 squared. And that could be your answer.